Problem number 6, suppose r double prime of t is the vector 2 comma 0, r prime of 1 is the vector 2 negative 4, r of 0 is 2 1, find r of t. So this is a initial value problem. So how do we tackle this? Well, let's see here. So r double prime of t is 2 0. If we, and let me write this in the I hat j hat notation, 2i plus 0j hat. If we integrate this once, we would get 2ti hat plus 0tj hat, that's just 0, plus our constant. What is our constant? We have a constant attached to the I hat plus a constant attached to j hat. And we are told that something about r prime of 1. Well, r prime of 1, if we plug in 1 here, we get 2 times 1 times I hat. So that's 2 times I hat plus C1, I hat plus C2j hat. And we're told from the problem statement this needs to equal 2I hat minus 4j hat. So what does this mean? C1 is equal to 0, C2 is equal to negative 4. So r prime of t is, with the initial conditions here, 2ti hat minus 4j hat. Okay, let's integrate this a second time. R of t is going to be t squared I hat minus 4tj hat plus, I'll use C3 I hat plus C4j hat to be the initial conditions, the constants here. And r of 0, yes, we're given r of 0 here. Plug in 0 in for t, and those are just 0. And we just get C3 I hat plus C4j hat. And from the problem statement, r of 0 is 2I hat plus j hat. So this shows us that C3 is 2 and C4 is 1. So putting all of this together, what is r of t? R of t is t squared plus 2 times I hat minus, I guess I should say plus negative 4t plus 1 j hat. So there is solving an initial value problem. Problem 18, write the vector u in the form v plus w, where v is the vector perpendicular to the plane, x plus y minus z is equal to 5, and w is a vector parallel to this plane. So u is the vector 2, negative 3, 1. We want to write it in the form something perpendicular to the plane, x plus y minus z is equal to 5, plus something parallel to that plane. And the important thing to realize here is that the whole point of giving you the equation from the plane is that you can write down very quickly a normal vector. The normal vector to this plane is 1, 1, minus 1. So really, what I'm asking you to do in this problem here is to find a decomposition of u with respect to this normal vector. This is perpendicular to the plane. So when I say, write it as something perpendicular to the plane plus something parallel to the plane, this is perpendicular to the plane, and something perpendicular to this will be parallel to the plane. So what do we need to do? We need to compute the projection of u on n here. And so that's going to be u dot n divided by n dot n times n. Okay, what do we have here? U dot n is going to be 2 minus 3 minus 1. That looks like negative 2 to me. And dot n is going to be 1 plus negative 1 squared. It's 3. And so let's see here. We end up with negative 2/3 times n times the vector 1, 1, minus 1. I'm going to write this as negative 2/3, negative 2/3, and 2/3. Okay, so this is the projection of u on n is negative 2/3, negative 2/3, negative 2/3. We also need the vector parallel to the plane. And to find that, we're just going to do u minus the projection of u on n. And so this is going to be 2, negative 3, 1, minus negative 2/3, negative 2/3, 2/3. And so this is going to be 8/3, negative 3 plus 2/3 will be, that will be negative 7/3. 1 minus 2/3 will be 1/3. So u is equal to v, negative 2/3, negative 2/3, 2/3. So this is the v that is perpendicular to the plane, plus 8/3, negative 7/3, and 1/3. This is the w that's parallel to the plane. And the way to check this is that we need w to be orthogonal to n. And sure enough, if you do this dot this, you get 8/3 minus 7/3 minus 1/3, you get 0. So that checks out.